Good evening, children. Let's start our session. So today I'll start about a new chapter called electromagnetism. So that is called magnetism and magnets. So let's start the topic now. Our topic is about magnets. Magnets. So here, what is mean by the magnet? Magnet is nothing but magnet is that it is an object which is attracting to substances. Magnetic substances is the object is known as a magnet. But the thing is how this magnet is introduced, how the magnetism have discovered in the science. Let's see now. Actually, this magnetism is discovered by a place called magnesia, and that place we have a material called magnetite. So the magnetite, the formula for magnetite is, so the place magnesia at the place of magnesia, at the place of magnesia, the people found that a ore, the ore name is called magnetite. The magnetite formula is Fe3O4. This is the magnetite formula. So at the place of magnesia, they found that a ore called magnetite. The ore magnetite is attracting the substances. From that, people got concluded that materials also will attract the objects. That way, the magnet have introduced. Understand how the magnet have discovered in our history. In a place of magnesia, they found a ore called magnetite. The magnetite is attracting the substances. From that, they concluded that materials will attract the other materials. The property is called magnetism, and the substance is known as a magnets. So such a way that we found that magnets. Now here we have some types of magnets. Now let's take the types of magnets. Next thing is types of magnet. Types of magnets. How many types of magnets we have? We have two types of magnets. First one is natural magnets, temporary magnets, and permanent magnets. Understand? Natural magnets and artificial. Broadly we can divide as two types. One is natural magnets, second one is artificial magnets. First one is natural magnet. Write down the natural magnet. Natural magnet. First one is natural magnet, second one is artificial magnet. What is this natural magnet? In the universe, substances which is having the property of magnetism by naturally, those known as what kind of materials? Magnetic materials. Those are called natural magnets. Here, this magnetite. So this magnetite is a material. This magnetite is a natural magnet. Understand? So here, what is mean by natural magnet? Naturally occurred substances which are having the magnetic property attracting the substances is known as natural magnets. So best example is what? Magnetite. And you know one that our earth is also, you can treat as a magnet. So earth is, you can take as a natural magnet. Natural magnets, your example you can write here. Example is what? For natural magnet, magnetite. Magnetite, that is Fe3O4, you can take as a natural magnet. Now what about the artificial magnets? So artificial magnets are nothing but man-made substances which having the property of magnetism attracting the magnetic materials are known as artificial magnets. So here artificial magnets have different shapes. The shapes of the artificial magnets are, I'll draw here. Artificial magnets you can take as a first one is bar magnet. Next one is a ring magnet. Disc magnet, and horseshoe magnet. This is a way different types of magnets you can take here as a artificial magnets. Horseshoe. What is that? Horseshoe. Horseshoe magnet. So let's take the shape. Bar magnet, the shape of the bar magnet is something like this. Shape of the bar magnet is something like this, north and south pole. Ring magnets are something like this, never end, it not having any end. And next horseshoe magnet is the shape of U shape. Understand, U shape. And the disc magnet is the shape of this way. This way we can observe the shapes of the magnets. Got my point? Next, the properties of magnet. So this is all about magnets. Next thing is magnetic needle. Magnetic needle. Magnetic needle. What is this magnetic needle? Magnetic needle is a device which is used to identify the north-south pole of the earth, because this magnetic needle will always, if you suspend in the air, if you suspended freely, it is always shows that north-south pole of the earth magnet, because the magnetic needle have poles, two types of poles, one is south pole, one is north pole. So south pole will attract it to the north pole of the earth magnet, and north pole is attracted the south pole of the bar magnet needle. Since this way it can shows the magnet, it can show the north south of the earth surface. So this magnetic needle even we can use in a compass to identify the north and south, to identify the direction of the roads, and as well as many where we are using this magnetic compass. This magnetic compass is working on the principle of magnetic needle, because the magnetic needle always shows that north south pole of the earth surface. With that we can identify the direction and position where we are of the earth. So this is the help of the magnetic needle. So this is the usage of the magnetism in our sciences. And next we can classify the materials based on the magnetic property. We can classify the materials in different way. Let's see the classification of the materials by usage of by property of the magnetism. Shall I? So here, if I draw the diagram of the magnetic needle, so this way we can see the magnetic needle diagram. This way we can see the magnetic needle. So it is always shows north to south of the earth surface. With this property we have we have developed the magnetic compasses. Okay, we have developed the magnetic compasses. So this is a magnetic compasses. By using this, we have developed a magnetic compasses. So this is the way I developed the compass. This is the compass and this is the magnetic material. Next, by using the properties of magnetism, we have developed the different kind of, we have divided materials as 3 types. Let's see the types of materials, of magnetic materials. Classification of the materials based on the magnetic property. Classification of materials based on magnetic properties. Classification of materials based on the magnetic property. So very first one is diamagnetic material. Diamagnetic material. What is meant by diamagnetic material? Diamagnetic materials are the materials which are not influenced by the magnetism. Understand? Diamagnetic materials are the materials will not influence the magnets, they will not influence the magnets. Example, we can take wood, plastic, paper. These are the diamagnetic materials. Understand? These magnetic materials, these materials will not influence with magnetic properties, and magnetism, it will not influence the magnetism. And same way, next one is, second one is paramagnetic materials. What is this paramagnetic materials? The materials which not allowing or which not attracted to the magnets, partially which not attracted to the materials are known as diamagnetic material. So which materials will attract partially or influenced partially are known as paramagnetic materials. Examples, these are the examples. Examples are, you can say, take that, examples are like bismuth, aluminium, manganese. These are the some examples for what? Paramagnetic materials. And also third one is ferromagnetic materials. So ferromagnetic materials. Ferromagnetic materials. What is meant by ferromagnetic materials? The materials which are attracting hardly or effectively to the magnetic materials are known as ferromagnetic materials. So here these ferromagnetic materials are influenced with magnetic properties or magnetic fields are known as ferromagnetic materials. See here, dia means not influenced with magnets, para means partially influenced with magnets, or ferro means completely fully influenced with magnets are known as ferromagnetic materials. Here examples: cobalt, iron, nickel. These are the best examples for what? Ferromagnetic material. So by observing all the things, so we can say that we can divide the materials into two types. One is magnetic materials, one more is non-magnetic materials. So magnetic materials again divided as how many types here? So diamagnetic is one thing, and para and ferro is one thing. So diamagnetic also comes under non-magnetic materials. Para and ferro comes under magnetic materials because these para and ferromagnetic materials are influenced with magnetic fields. So that way we can divide the substances into three types. And the next, if you see, if you observe the any magnet, if you let me take another page. If you observe the magnet, it has a poles. So let's discuss about magnetic poles of the magnet. So magnetic, keep a side heading, magnetic poles. So here any magnet have two poles. In the universe, no single pole cannot exist. Every time magnet will available as a pair. So the pairs are nothing but one is north pole, one is south pole. Understand? So here, so north pole, and one more is what? South pole. Here, if you observe the magnet, any magnet, let me take a bar magnet. So I am taking the bar magnet. If I take the bar magnet, this is a bar magnet. For this bar magnet, this is the north pole, this is south pole. See, north pole and south pole is the ends of the bar magnet or any magnet. So north pole and south pole are the ends of the magnet. So this is north pole, this is south pole. If you say in terms of the magnetic lines, always magnetic lines are start from the north pole and ends from the south pole, and inside the bar magnet the magnetic lines are passing from south to north pole. So if you see, if you keep every north pole will attracted to south pole, or else every south pole will attracting the north pole. So now still we can tell that many things about north pole and south pole. Those are nothing but south pole and south pole will repel, north pole and south pole will attract. So this way we can talk about south pole and north pole. So once again I am stressing you, in the universe only a single pole cannot exist. Every time any substance, any magnetic substance always having north and south pole, no single pole cannot exist. And next, if you freely suspended any magnetic material, the magnetic material always shows that our magnetic bar magnet, if you suspended the bar magnet freely in the air, it is always oriented along the direction of the south and north pole of the earth magnetic field. See, north pole of the bar magnet shows the south pole of the earth. The south pole of the bar magnet shows north pole of the earth. Such a manner, with this property only, we have developed that compass needle or magnetic needle. So this is all about north pole and south pole. And next we have properties of magnet. So let's talk about properties of magnet. So better write down. We have properties of magnet. The first property is attractive property. First property you can write down. Attractive property. Second property is directive property. Second property is directive property, and third property is law of magnetism. Law of magnetism. Let's talk about one by one this attractive property and directive property and law of magnetism in a next slide. First property is, first one is attractive property. Write down attractive property. So first one is attractive property. What is this attractive property telling to you? The attractive property is nothing but any magnet, if it is influenced with the magnetic materials. For example, if you take any bar magnet here, the bar magnet having north pole and south pole. If you keep any magnetic material near to this bar magnet will attract that magnetic material. So that is nothing but attractive property. For example, magnetic materials, best example is what? Iron. If the iron needles keep near to this bar magnet, the iron needle will attract that, this bar magnet will attract the iron needles, but it cannot, it cannot repulse the iron needles. It is always attracting the iron needles. Understand? If you keep any cobalt material near to this bar magnet, the cobalt material will attracted by this bar magnet. So because this having always attractive in nature, and when it will repel that objects, then if it is opposite nature, if any material having opposite nature, then only it will repel. If it is same nature, any having the same nature, then only it will repel. For example, if you keep any bar magnet here, this is north pole, this is south pole, and this is north pole, this is south pole, and this is north pole, this is south pole. This south pole, north pole will attract here, and if you keep north opposite each other, this is north, this north, this time they will repel each other. In this case only, like poles will always repel, unlike poles will always attract. So when you are keeping near any magnetic material, always the magnetic material will attract. But if you keep near to the any bar magnet to the other bar magnet, if the unlike poles will attract, like poles will repel here. And also, if you see the once again about this property of poles, just now we discussed that. In this case, we discussed that poles color. Here, if you see any magnetic material, for example, this is a bar magnet. This bar magnet having north pole this side, south pole this side. Now, if you break this bar magnet as a two pieces, the two pieces also again will form two other poles. Here here north pole will form, here south pole will form, here north pole will form, here south pole will form. Again, if you make any small pieces also, the small pieces also having poles north and south. Understand? So that way the poles will existed for any magnetic materials. Understand? Coming to this point, just now we discussed the attractive property here. The attractive property means always the magnetic materials will attract the other magnetic materials. In the case of bar magnets, for same poles will repel, unlike poles will attract. Here same pole means north and south. You can write here north will repel, south also will repel, north south will attract, and any magnetic material any magnetic material will attract other magnetic material. Understand? This is the way we can define the attractive property of the magnetic materials. Next, directive property. Let's go for the directive property. Better write down directive property. Already this directive property we have been discussed. The directive property is nothing but if you suspend any magnetic material into the air, it always shows that north-south pole of the earth magnet. Based on this property only, we have found that we have developed that compass needle or magnetic needles. Understand? So once again I am repeating, if you suspend any magnetic material into the air freely, the freely magnetic suspended magnet always shows that north-south pole of the earth magnets. So based on this only we have developed the compass needles. So now I am suspending, let me take, this is a rigid support, I am suspending a magnetic material here. If I suspend here magnetic material here, so this is the way it always shows north south. Any if you change any orientation of the needle, it always comes to the rest north south pole of the earth magnets. So that way we can conclude that the object is a magnetic material. Understand? It having the direct, this is known as a directive property of the material. And also next one is laws of magnets. Next property is, one more property is there, the property is laws, other property is laws of magnetism. What is this laws of magnet? Already this laws of magnetism already I discussed in the case of poles. The laws of magnetism is what? Like poles will repel and unlike poles will attract. These two things, you know, these two statements is known as laws of magnetism. Understand? These two things you known as a laws of magnetism. So what is that? According to the laws of magnetism, like poles will repel, unlike poles will attract. So these two things you known as means north, south will repel, north south will attract. And one more property also there, that is nothing but pair property. Last and final thing here, one more property, that is pairs property. Pairs property. What is this pairs property? Already when in the case of the poles I discussed this pair property. So here every time the poles will existed as a pairs, no single pole cannot exist. Understand? Once again I am repeating, every time the poles will existed as a pairs. Understand? So pair property, what is this pair property? Every time poles will exist as a pairs, that is north and south, single pole cannot exist. Single pole cannot exist. Like isolated north and isolated south cannot exist. Understand? So very important. Isolated north, isolated south cannot exist. If they are existing, that is representing that ideal condition. Understand? South pole, north pole, if they are existing isolated, it means that it is a ideal condition. The ideal condition they are considering. Generally, practically, the isolated north pole, isolated south pole will not exist. Based on this only, just now I discussed that point. If you make this is a bar magnet, this is the north pole, this is the south pole. If you break into many pieces, or for example 2 pieces, the 2 pieces will have again north and south pole and north and south pole. That way the pairs will exist. When we are separately break that, it cannot be have a single pole. It always having, even to break into this piece also, north south, north south, north south, north south. That way the pairs will exist. Any tiny magnetic material also having pairs of poles, that is north and south. The single pole cannot exist. Understand? So this is what today's topic, and tomorrow, the coming classes, will explain about other part of this magnetic materials and magnetism. So today I'll stop the session. Bye.